My name is Jonathan Lin. I'm an MD PhD student at Washington University in St. Louis, completing my PhD in the lab of Dr. Rajendra Apte in the Department of Ophthalmology. And I'm currently a clinical medical student finishing up next spring. So in Dr. Apte's lab, we're broadly interested in understanding kind of the role of the aging immune system in the pathogenesis of age-related macular degeneration, a leading cause of blindness in older adults. And so past work in his lab has shown that as these key immune cells known as macrophages age, they kind of change how they behave in the body, and this kind of promotes disease. And so the question I wanted to answer was trying to understand. So there have been a lot of studies identifying different facets or different elements of macrophage function that are perturbed with aging. And I wanted to focus specifically on understanding why these cells change. And so one of the key molecules in biology are known as microRNAs, and these are essentially non-coding RNAs that have an important regulatory process by regulating protein expression. And so we hypothesized that in this kind of aging macrophage process, there may be one or multiple microRNAs that play an important role in kind of skewing macrophages from a young, healthy phenotype towards an old, dysfunctional phenotype that promote disease. And so through our work, we identified one such microRNA, microRNA 150, that is upregulated in aged mouse macrophages, but also in diseased human macrophages, and that our studies suggest that this might be one of the ways in which macrophages kind of become dysfunctional and promote neovascular AMD.
What are your next steps in this line of research?
We're very excited about the translational possibilities of this research for a few reasons. One, because we think it opens up a lot of new potential therapeutic avenues for a neovascular AMD. Of course, these studies are going to require a lot more work before we can kind of get there, but whether it be through microRNA-based therapies, since this microRNA is upregulated in aging, it could be possible to think about trying to antagonize the microRNA to help ameliorate disease. In addition, we think it's very valuable as it could be a potential biomarker to guide therapies and treatment options. In our human kind of data, the levels of this microRNA do seem to rise in early forms of disease prior to kind of the development of a neovascular phenotype. So it is possible, pending more validation studies, that if the levels do indeed increase prior to kind of later disease, they could be a way for us to predict which patients will transition or kind of develop these the wet form of advanced disease versus more of a dry geographic atrophy form. So it may be useful for guiding, as a biomarker for guiding treatment decisions and treatment planning.
How will this line of research translate into patient care?
So, as I discussed earlier, I think we're very excited about the translational possibilities of this. I think one of the things that's being looked at now is, basically the fact that for most, so we have the VEGF therapies are outstanding and they can work for the patients that they work for. But for patients who respond to these VEGF therapies or are under-responsive, we're hopeful that these kinds of lines of investigation will one day lead to the development of new therapeutic approaches, which could help these patients who can't, or don't respond well to VEGF. In addition, I think it could also play an important role in the future for helping prognosticate maybe for patients. It is very hard to predict now patients who develop early AMD, which will transition into, disease, advanced forms of disease, which form of advanced disease they'll transition to, whether it be more of a neovascular wet form versus a dry form. And so we think it's possible that these kinds of investigations looking at things like microRNAs and other biomarkers may also help guide, counseling patients. Like, you have a higher chance of developing this form of disease versus, or kind of the time course of that, and also guiding treatment therapies, whether it be VEGF or in the future, hopefully other non-VEGF options.
Are your findings different for the wet form as opposed to the dry form, or is it pretty steady across the
Yeah, so our studies are focused pretty much on neovascular AMD, and that's kind of our kind of model system is kind of designed to look at that. And so we haven't explored this very much in advanced dry AMD. That would be definitely something that we're interested in looking at in the future.
Perfect. Is there anything you'd like to add?
I don't think so.
Great. Well, thank you so much for coming and talking to me.
Sure thing. Thanks for the opportunity to share our work.